Hello everyone. This video is going to be about patterns and how we can define them and all the different kinds of patterns there are. So patterns are formed by the repetition of elements so that you can actually predict what's coming up next. Because a pattern repeats itself, a real pattern keeps repeating itself. So you can kind of predict, even if you haven't seen it, what's coming up next. You can predict what that is based on what has happened before. So a pattern can be short. For instance, if I say 1, 2, 1, 2, 1, 2, 1, 2, that's a short pattern. And you can pretty much guess that my next word is going to be 1. Right? It's a short little pattern. It can be also very long. It can be a long pattern, which we'll see some longer patterns later on. And it also can be a pattern that is created that you don't really see the pattern. And it's a little harder to decipher because a pattern is hidden underneath. And you have to figure out where is the pattern. So let's take a look at some different kinds of patterns, starting with a pattern based on shape. So here is a pattern and all the elements are green in this pattern. So the color is not a big deal, but the shape keeps changing. And how does the shape change? It changes from a rectangle, right, to a triangle, to a circle. And then again, rectangle, triangle, circle, rectangle, triangle, circle. So what do we see here? So where is my pattern? My pattern is here. My triangle is repeating, my circle is repeating, and they're repeating in order, right? So they're repeating on the same order, and that's a pattern, okay? So that's a pattern based on shape. Now, there are some examples of patterns in nature. Nature is excellent at creating fantastic patterns. And I think the reason for that is that patterns fill up a space in the most efficient way possible, right? So if you imagine, for instance, let's pull this up here. This here is a honeycomb pattern based on shape. So these shapes are really the best way that the honeybees figured out how to fill the whole area with the least possible amount of shapes. So these shapes that repeat here are hexagons. So you're going to see these later on in geometry, but these are hexagons. And as you can see, they're very neatly put together in that every side of one hexagon fits on the other perfectly. And that is because it is all about efficiency and how can I save as much honey as possible in this little area that I have. Very efficient, and it is a shape pattern, right? Because what makes a pattern? Basically, I can tell what is coming in this side here, right? I could probably draw what is here, right? Just based on what I see, right? So that's a pattern because I can do this, okay? All right, so what other kind of pattern do we have? We also have patterns of shape and color. So I just copied the same pattern that I had from before. And as you can see, it is the same pattern. You know, it starts with a rectangle and then it goes triangle and circle. But this time, we're also changing the color of our patterns. So of our pattern. So it starts with green, yellow, red, goes back to green, yellow, red, green, yellow, red, green, yellow, red, so that the next element of this pattern string, I can probably guess it's going to be a green rectangle, right? So the next element would be a green rectangle. What is a good example of this kind of pattern in nature? I was taking a look and I found macaw feathers are really nice examples of patterns that utilize shape and color. And it depends on the area of the macaw. These here are from the macaw wings. So the wings of the macaw have tips of the one kind of macaw. There's so many different kinds, but the tips are blue, and then it goes into a red, yellow, and then it goes into a white, gray. And all of them are the same. If you take a look at how this organizes, it forms in the end a pattern. And so as I said before, the higher feathers change color, right? So it's not all the same pattern, but for every area, it follows that pattern really well. As you can see, these all are tipped green, for instance, right? So is it perfect? No. Mother Nature is not perfect, but Mother Nature is very interesting. So here is a whole macaw with all the patterns and all the feathers, and it forms a whole picture from far away, right? Okay, and what about other kinds of pattern? Can we have a pattern that has color but also rotates? We certainly can. So this is a string, this is my whole pattern, a string of flowers that have 5 different colors, and the colors rotate. So these colors rotate. This one here is yellow, right? This yellow here, I'm just gonna get another color for my pen because I'm getting a little lost here. So, okay, so this color here, for instance, okay, the yellow, let's go with the yellow. The yellow is here. On my next flower, the yellow has rotated to the next petal. And on this flower, the yellow has rotated to the next petal, and the next petal, and the next petal. So it's the same for every single one of these colors. All they're doing is rotating to the next petal, right? The red, the purple, the blue, and the orange, they're all doing the same thing. So what's going to happen then on my next flower? If you take a guess, my next flower would be the same as this flower here. It would go back because the yellow now will be here, right? Just like here. So it is a pattern of color because the colors repeat. You can't now all of a sudden say, okay, this yellow is now white, because that wouldn't follow the pattern, right? So it's going to be exactly the same as this, and it's going to repeat over and over and over. So that's a pattern of color and rotation. Now I found one really interesting example of color and rotation in nature, and I'm going to pull that up here. So sunflower, the center of the sunflower, if you look at each individual, because it's very confusing, right? It's filled with stripes and everything. But if you look at every individual stripe that goes down like this, I'm going to pick a different color. So if I look at a stripe of information, okay, this stripe of information here actually repeats all the way around, boom, 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 all the way. So it is the same color, okay, because it starts with a little bit of green, it goes into the yellows and oranges and everything, then it ends on the poofy. But it rotates all the way around, so that if let's say I lost a piece of the sunflower, if all of a sudden I'm missing this piece of the sunflower, I would be able to fill that in based on all the information and the logic that I see on the rest of this image. Okay, so that's how this works in nature. I'm going to just take these out, and we're going to go look at the next type of pattern, because there is more. Number and rotation. Okay, so number and rotation patterns are starts getting a little, more interesting, I think, a little more complicated. So if you look at this, it's hard to tell immediately what the pattern is, right? It's like, meh, I don't know. But if you look at each individual one and see what changes on the next one, look at the first one and see what changes on the next one. So the first one that I have here, right? Let me change my color again to white. This is a little brighter. First one, the dot is on the top left corner. On the second one, it's top right corner, right? And then it's basically, it is rotating. I know that it's rotating because this one here, he went from there to there. So that's where he went to. And after a few, he rotates over to that side there, right? So now it's here. It is totally rotating. The points are rotating, but it's rotating in a weird way. And how is that? I have one unit with the point with a little dot on the top left, and then I have 2 with the little dot on the top right, and then I have 3 with the little dot on the bottom right, and then I have 4 with the little dot on the bottom left. So it is a pattern. It is adding 1, 1 plus 1 is 2 plus 1 is 3 plus 1 is 4. But it is a hidden pattern. It's kind of hidden, right? Kind of messed up a little bit there. So it's a little bit hidden. But if you think about it this way, 3 minus 4, can you guess what the next part, what the next portion of this pattern is going to look like, or even the next element of this pattern is going to look like based on this? I'm going to give you a second. While you think, I'm going to erase some things here so I can have space for my next element. So the next part of my pattern is actually going to go back to here, because I'm on the very last one. I'm down here. It's going to rotate up and it's going to go up here. Now, how many of them? Well, since I have 4 here, our next thing is going to be 5. So I'm going to have 5 with the dot on the top left corner. So that's a pattern based on number and rotation. And a good example of this that I found on Nature is this plant here. I think it's a succulent of some sort. If you look at it, it starts near the center, near the top, with like a couple petals, and then the next layer over is 3, and the next layer over is 4. The next layer over is 5, and the next is, and it starts getting bigger, starts skipping actually, and then you get confused. But you see how it is also, it's rotating slightly, right? It's everything rotating slightly and adding more numbers. So that's kind of a pattern of number and rotation. The colors are always the same. All these leaves look the same, but there is a pattern that is based on the number of petals and the rotation and how they are getting fitted together, which is really neat. So that is number and rotation. We're going to take a look here. What is our next that I have prepared? Our next type of pattern. Patterns of numbers, finally there. Okay, so this here is a string of odd numbers, right? So what makes this a pattern? Well, basically I am adding 2 to every one of my numbers. So every one of the previous numbers, I'm adding 2, and I'm adding 2, right? Plus 2. And that's how it's going, okay? So this makes it a pattern. I'm repeating one thing that I'm doing, and it's the same thing. So it makes it easy for me to predict the next number, because the next number I know based on my pattern and what I'm trying to understand here from the information that you are given, right, that it's going to be plus 2 as well. So 9 plus 2 would be 11. So the pattern here is previous number plus 2, right? All right, so I'm going to erase my calculations here to get to it. Previous number plus 2, my prediction is 11, right? My next number. So if I give you this one here, now this is, if you look at it, the first thing that I notice is that it's not an odd or an even. So it is a little harder to figure it out. But if you follow the same principle, you just look at the first one and what was changed to the next one. So you look at the first one, it's a 3. To 6, 3 plus 3, 6. So if I add 3, and it's the same with every one, plus 3. Awesome, it works. So that worked really well. I tested it, it worked, I'm happy. So my pattern is previous number plus 3, okay? So that was an easy pattern actually. After we saw the first one, this was pretty easy. This one here, however, starts getting a little more complicated, right? I'm actually going to move my head over. Woo! She has moved up to the top corner. Hi. Okay, so If you look at this pattern, okay, it starts with 1 and then it goes to 3. So 1 plus 2 is 3. So if I add 2 to 3, it's 3 plus 2, it would be 5. So this does not work here. And that's what makes patterns in math. Sometimes you have to think a little bit, but this is not difficult. It's actually quite fun. So 3 plus 3 is 6, okay? And then 6 plus 3 is 9, so that is not it. But 6 plus 2 is 8. So plus 2, 8. 8 plus 3 is 11. And 11 plus 2 is 13. And 13 plus 3 is 16. So look at this. It goes plus 2, plus 3, plus 2, plus 3, plus 2, plus 3. So basically, your pattern is there. It's just, it's a little more difficult to see. So it's a plus 2, plus 3, plus 2, plus 3 pattern. So based on that, excellent. What is your prediction for the next number? The next number will be 18. And the next number after that, 21. Okay, so these are some patterns with numbers. We're going to be seeing a lot of patterns. I really love patterns, especially visually. But as well as mathematics, it's really fun. It's just like doing a puzzle. It's super fun. And last but not least, I just want to show you how it disappeared. So I just want to show you, this is a simple search on patterns in nature. I really recommend taking a look at patterns in nature. It's amazing, all the patterns that you see when you do that. From like tree rings to nautilus to leaves, everything. Even the little hair, the little papilla from our tongue follows a pattern. So it's really cool. I hope you guys enjoy patterns. I'm really excited about working on this with you guys. I'm going to have tons of really fun projects, and I'm going to take this away so I can see my face again. Okay, we're going to have a lot of really fun projects, and I hope to see you soon. Okay, bye-bye.